Welcome back to section 5.4 of our modeling and optimization section in our calculus. We're going to be talking a little bit about economics today. Just a quick reminder, we've got some definitions. The function R of X represents the revenue, C of X represents our cost, and the first derivative of R and the first derivative of C represent marginal revenue and marginal cost, respectively. In other words, what happens at the edges, what happens at the margins of my function. So we're going to look at profit today, and what we're going to be looking at is the definition of profit. A simple definition is revenue minus cost. Maximum profit, our critical point, will of course be the first derivative of profit is equal to 0. Well, that means that the marginal revenue minus the marginal cost is equal to 0, which means that the marginal revenue is equal to the marginal cost. Therefore, our maximum profit will occur when marginal revenue is equal to marginal cost. Let's do a quick example. We have a situation where our revenue function is equal to 9 times the number of units we produce, and this will be in thousands of units. That the cost function is defined as x cubed minus 6x squared plus 15x. We can therefore find our marginal revenue by taking the derivative and our marginal cost by taking the derivative. Maximum profit occurs when we set these equal to each other. So we've got 9 is equal to 3x squared minus 12x plus 15. Using the quadratic formula, what we get is that x must be approximately, sorry, I had to turn the page back here, approximately 0.586 or approximately 3.414 thousands of units. Now, remember, these are critical points. These are not necessarily maximum or maxima. We know that our profit was equal to revenue minus cost. And so what we can calculate is the second derivative of this function will be equal to negative 6x plus 12. And I skipped some steps in there because I didn't use the profit equation directly. Doing some quick calculations, the second derivative of 0.586 is in fact greater than 0, implying that this is a minimum. And the second derivative of 3.414 is less than 0, implying that this is a maximum. And therefore, this is the number of units we should produce to generate maximum profit. All right. Our next and last video will be using average cost to calculate maximum profit. Thanks for watching and hope you learned something.